Table 2 shows truth table. Use the truth table to draw the logic gates used. So we have inputs. We have input where we have B, C. We have B and C, which will get not M. So this not M, this is the same as when we have M bar. Then we have AD, where we have A and D, we get N. And the output is M or N. Remember, this is Boolean algebra. We don't say M plus N, we say M or N, which is equal to not O. So this O is the same as O with a bar, because it is the complement. We can use the apostrophe for a complement. Now here, what you have to know, or to approach this question, you have to go step by step. For example, here we are seeing that we have B and C, and this B and C, they are being multiplied. We have some logical multiplication and we get a not M. Meaning, for example, in binary, we know 0 and 0, we get a 0. So the result of B and C is complemented to get a result M. That is what is happening here, because 0 and 0 is 0. 0 inverted, we get 1. So meaning, first of all, you have to pass these two inputs B and C in a gate that represents AND operation, and this gate is the AND gate. So in this case, we are going to take B and C, we put them in an AND gate, and these two will give us B times C, or B and C. Remember, the output at this point is negated. The output is negated. Remember, here we are told we are getting M, we are getting not M. So in this case, we can say B and C is M, and to get not M, we can pass this to a NOT gate to get not M. So in that case, now the gates that have been used here is an AND gate, where B and C are passed inside it. Then we pass the output of BC, the output of this gate, to a NOT gate to get the complement. That is that. Now let's consider A and D. A and D, they are being passed to an AND gate because this is a logical multiplication. We get N. So you can check the difference here. Here we are complementing the AND operation, but here we are not complementing, because 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. So we are taking A and D, and we are passing them to an AND gate to get A and D, which is the same as N. So there we are not passing it to any other gate. So after that, we are having, in the output, we are having M. Remember, M here is not having a complement, is not having a bar. So it means our M here, to go to the final output, will be complemented further. Meaning, And the gate that is used in M or N is the OR gate. So it means this complement M, we pass it through a NOT gate again to get the M which is being used at the output. Then here we are having the N which is not changing. So in this case, we are going to pass our M and N through an OR gate, whereby now we are getting the OR gate will give us a M or N. But remember the final, which we can call it O. But finally, the output of the two is complemented O, meaning let me illustrate here. The output of this gate is M, and that is M or N, which is the same as O. Let's not complement O at that point. And this O at the final output, very final output, is complemented, meaning we are going to add a NOT gate at the end in order to complement O. So the final gate here will be a NOT gate in order to get NOT, not O. So that is it. That is how you draw those gates. You pass B and C to AND gate, we get B and C. Because we are getting complement of M, complement the output, you get B, M complement. The final output as M, so you complement M not to M. Then you take A and D, you pass them to a normal AND gate, you get N. Then you already those that the M and N to get O, where O is now complemented using NOT gate to get NOT O. And also remember, in this point, at this point, instead of drawing OR gate and a NOT gate separately, you can have a NOR gate. That is, you can have an XOR gate whereby you complement at the output. So you can attach a bubble at the end, or you can draw separately. In whichever way it is allowed.